Namaste. Welcome to the Verilog session. Now we are going to learn how to implement all the basic gates like AND or the major three basic gates AND or NOT in our FPGA board. That means by using the Verilog. So for that, first of all, we just need to go to the search and just type ISE because we are using the ISE tool. Okay, so for writing the program and implementing that to the board and even with the test bench, so just type ISE and it will going to open the project navigator as I told in the previous video. I think you are familiar with this now. Just click OK. Then here we just have to create the new project. It will just going to display the previous project that we learned, that is the basic implementation of the AND gate. Hope you watched that video. If not, just go and just watch that and just click on the new project. And here again I'm going to call this as a basic gates and this HDL and that clicks next. Yeah, it's already there. So what I'm basic gates new, I'm just going to call that as basic gates new. Then here all those FPGA onboard these things. I think you're familiar with this, some of the things written in this here. So you just need to set which board you are using and all those things here. Okay, this type I'm using the Spartan 6 Xilinx Spartan 6 FPGA board I'm using. And just here make sure you are going to use the Verilog. Okay, we are writing our program in the Verilog, so just use the Verilog. Click next and yeah, finish. Now we are in the project inside the directory. That means and here we have to create our Verilog file and whatever the file we have to create, that means the pin configuration file, all those things we have to create here. So just right click on it and click on the new source and Verilog module, and I'm going to call this as a basic gates. Anything you can give. Okay, just basic gates and click next. And for the basic gates and or and the not, so we need the two inputs A and the B. So A is my input and B is my output. So you can even give the here or you can directly given that in the program. So let's try directly giving that in the program. Just it is just a graphical interface, that's it. Just click next, just click finish. So here you can see it's nothing is there now, just empty. And here I'm going to the output and the input. This my just for a convenient I'm writing the output first. Output is AND gate and OR gate and NOT gate. So three gates are there, so three outputs we need to mention. That I'm going to call this as a Y1. That is the just remember this Y1 is for the AND gate and Y2 and Y3 or and the NOT gate, and or not. In this sequence we're going to design and input A and the B. Okay, you can just comment just to remember Y1, this is for the this is for AND gate, and Y2 this output of the OR gate, and Y3 this is for the NOT gate. Okay, then we just defined all these things. Now we have to write which is the output. Output is Y1, Y2 and Y3. Okay, then input 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 is A and B. Okay, we don't need any intermediate states, that's called as the wire, that we not require here. So just input and the output, and here we are going to write that using the data flow modeling. So for that I think you remember the syntax, that is assign keyword followed by whatever the output and statements like that. So ASSIGN assign. So for the AND gate my output is Y1. I need to assign this to AND of A and B. So A and B. Okay, then just every sentence has to be ended with the semicolon. Just click on semicolon, then assign y2 equals to A or B, or is just like a this pipe symbol, okay, A or B, then ASSIGN Y3 equals to I'm just going to make the not of A. So for the not, here is the symbol, that means that like this. What's that? I'm just going to call that as a reverse, as I don't know its exact word. Just think about its exact word and just give that in the comments so I to know that. So just yeah, A, not of A. Okay, then yeah, that's it. It's a very simple code, and we just need to check for its test bench. I just saved this, and for the test bench we have to be in the simulation, because we are, first of all, we are simulating, and if we get the correct output, then we are going to implement that in the real board. So here just click on this and new source. I'm going to use the source as Verilog test fixture, and here name, I'm going to call this as a, okay, we just call this as a test bench. Click next, test bench for my basic gates module. Here you can see the name, these two are same, then click finish. Now it will automatically create that test bench for only one values like 0 0. Here we can see, just remember this name. If you are writing this test bench from the scratch, that means if you just delete all these things from the scratch, then you just need to remember that the input has to be the reg and this register, and the output has to be the wire. Here you can see this is just a module, and here whatever the name that we have here. So not here, yeah, I just need to click here, and here whatever the name that we have here, that same name we just have to use in the test bench too. So here that same name, and here too, yeah, here, okay, this is what the name that we give for this one, that is test bench. So here we have to use that same name, and here any name you can give. So here they given this is unit under test, so they just given this as a UUT, any name you can give here. Okay, then from here the initial block, that means the initial begin and the end, that is going to execute its one by one sequentially in the simulation. So initial block is used, so it is the initial inputs A equal to 0 and B equal to 0. Then yeah, I'm just write like this, A equal to 0 and wait for a 100. Okay, wait for 100 nanoseconds. Then again A equals to, yeah, the same thing we have to do for others thing too. So A equal to 0 and B equals to 1. Okay, B equals to 1, and again wait for a 100 nanoseconds, and then A equals to 1 and B equals to 0 and 100 nanoseconds. Then you just copy paste this same thing, and then A equals to 1 and B equals to 1. So this for just a 4, that means possibility 0 0 0 1 1 0 and 1 1. Yeah, that's it. We just have to save this and just click on this, just select this test bench and just click on this. Here we're going to get the simulate behavioral model. If you get one error that I remember, just comment it below. Okay, yeah, we got here, yeah, here we can see the Y1 is for the AND gate, Y2 is for the OR gate, and Y3 is for the NOT gate, and AB are our inputs. So here we can see, yeah, from the beginning we just see, yeah, this is for the first 0 0, AB is 0 0, Y3, that is the NOT gate, that is going to be 1. Here we can see that this is at 1, and the remaining OR and the AND gate outputs, that is going to be 0. So whenever I click the next, then here you can see it is 0 1. So yeah, 0 1, so that means 0 1. Okay, 0 0, yeah, 0 1. So here we can see Y3, the NOT output is 1, and this the OR output is 1, and the y1, that is the AND output, is 0. I think you've understand these things. So here now it is 1 1, so A is 1, so y3 is 0. In the previous case, the A is going to be I think yeah, A is 1, so y3 is 0. Okay, whenever the A we implemented the NOT gate for this A, so this will going to change with respect to the A. I think you've understand this. So yeah, 1 0 1 1. Whenever it's 1 1, it is 0. So yeah, when it's 0, it will going to be 1. I think you have understand this. For the 0 0, just carefully observe the AND, OR and the NOT output, and this is for a 0 1, and this is for 1 1. I think what is that, 1 0 0 0 0 1 1 0 1 1. Yeah, all these things are there. We just yeah, check that once. Yeah, here it will just going to show the transition that we selected here. So for example, if I selected this y3, then if I click this, then here we can see we are going to see only the 3 values. But if I select on this B, that is our LSB, that means it is going to change at each sequences. It will going to change from 0 1 1 0 like that, 0 1 0 1 like that. So if we click here, then we are going to get the 4. Whenever it is 0 0, then 0 1, then 1 0, then 1 1. So 4 different possibilities that we can simulate. From the simulation we can get. Okay, then now we are going to implement this. Now I think you have understand this basic gates is the thing. So now just go to the implementation, and the next step is we need to add the Ucf file. So for that, yeah, just click on this, click on the, yeah, just click yeah, basic gates here, just click on this, add new source, and Ucf, that's user constraint. Yeah, where is that, implementation constraint. Okay, then here name, I'm going to call this as a basic gates pinout, basic gates pinout. Okay, then click finish. So here we just have to get the manual or anything of that board you are using. Then I'm just going to use, now this time I'm just going to use these switches for my input. So 1 2 3, yeah, we need only 2. 1 2, this for A and B. I'm just going to copy that, and here, okay, this is for the input. This is switch called as say A, and input, my input. Okay, and this is B, and for the output I'm just going to use simply the any on these LEDs, because that's better we can see. So I'm just going to use 3 LEDs we have to use. So I'm just going to use this D2, D3 and D4. So D2, D3 and D4. One is for AND, another one is for OR, and another one is for the NOT gate. So yeah, this is for AND, and this for OR, and this for the NOT. So here my output is Y1. Just remember, you just have to change this Y1, Y2 and Y3. Control S, and now I have to generate the program file, and I have to just connect my board. So here you can see that the board is like this. I'm just going to connect it. Yeah, now it's connected. Okay, and here it is going to create these files. So just wait for some time, it's going to create. Yeah, it's almost the generating the programming file, so it takes around 10 to 20 seconds. Okay, after that you just have to click on here, manage configuration project. So we need to add the device, so just click on this, and it's going to open a window, boundary scan and initialize chain. So yeah, here it detected, and it's asking for us to add the bit file, that is the basic gates new. So basic gets new, basic gets.bit, click open, and here just click on no, and yeah, click OK. Then here you just have to add this. Oh, before that I'm just going to show this, and I'm clicking this and program. Now it's programmed, and here you can see now these are my switches. So yeah, I think it's something issue again. I just restart this. Okay, this is the reset button, and program. I will just try. Okay, wait for 1 second. Yeah, I think I have a small error here. I just this much is extra here, that's why it's not coming. Okay, now we'll just generate it again. Be careful if you change these numbers, or if you add anything extra, that's not advisable thing. So yeah, now it's generating. Yeah, now it's successfully generated this programming file. Now you just need to manage configuration project, then boundary scan, and just initialize chain. Okay, now it will going to detect this. Just click on this, and you just start to click the bit file. Okay, choose the bit file, click OK, and click no, and yeah, here okay. Now yeah, here you can see that not here, sorry, yeah, this one, where I can see this. Now yeah, I'm just going to program this. Yeah, now it's successfully programmed properly. So here you can see the A and the B, which is at 0 0. So I'm getting the output here as the NOT gate. That means this is for the AND gate LD2, and this is for the OR gate, and this is for the NOT gate. So the NOT gate output is 1. And if I make this as a 1 1, then please tell the output what is that. If I make the 1 1, the AND gate output is 1, OR gate is 1, and the NOT gate is 0. Let's verify that. I'm just going to make these two as 1 1. Okay, I think yeah, as 1 1, I think it's okay. Yeah, it's just stuck, I guess. So yeah, now it's 1 1. So here you can see the NOT gate output is 0, and the OR gate is 1. So if I just make this as a I'm just going to make this as a 0 1. So now you can see, yeah, it's just focusing. Yeah, now it is a 0 and 1. So the NOT gate output is 1, because it is connected to this A. It is 0, so it's 1, and AND gate output is 0, and OR gate output is 1. So I think you come to understand this, how to do and all. I'm going to share all these things. Thank you. If you like, just share.